So previously we looked at doing a bubble sort, happy days. What we've got here is our code which does the bubble sort, but there is an issue with this code. It works, but it's not what we call very efficient. Why isn't it very efficient? Well, that's what we're going to be looking at now. Well, if we were to sort this out, I'm going to count the cycles of how many times it's going to take us to get this list into order. So cycle 1. Is 3 bigger than 1? Yes, it is, so let's swap. Is 3 bigger than 2? Yes, it is. Swap. So it's still in cycle 1. We're still going through this list. 3 bigger than 4? No, it's not. Is 4 bigger than 5? No. 5 bigger than 6? No. 6 bigger than 7? No. 7 bigger than 8? No. So we've cycled through one time, and now we have our list is 1, 2, 3, 4, 6, 7, 8. We're done. But this outer loop is saying, yeah, and we might be done, but we're still going to do this another 7 times, well, 6 times. So it then loops again. This cycle through. Is 1 bigger than 2? No. Is 2 bigger than 3? No. Is 3 bigger than 4? No. Is 4 bigger than 5? No. Is 5 bigger than 6? No. 6 bigger than 7? No. 7 bigger than 8? No. It's then going to loop again, and it's then going to loop again. And even though we've got it sorted out in order, we call that inefficient. So what can we do to make this efficient? Well, we're going to change certain bits of code around. What is it that we want to keep? I want to keep this if statement, because if statement is check and see if one number is bigger than the other. I want to keep the temp, obviously. I want to keep this for the swaps. So we're going to keep that. I also want to keep this for loop, because this for loop, the inner one, is responsible for comparing this against this, this against this, this against this, this against this. That's its job, so we want to keep that. The issue is this for loop, the outer for loop. What type of loop are we dealing with here? Well, we're dealing with a count-controlled loop. A count-controlled loop basically will run a set number of times no matter what. Think of another type of loop we could use where it would stop when we don't need to go anymore. You got it. We could use a precondition loop, i.e. for while loop. Pause the video and see if you can come up with a way for this code to keep repeating until it doesn't need to repeat anymore. You may need to add a new line of code above, but make a tweak to it. I'm going to do a solution. See you on the other side. What I'm going to do to begin with is I'm going to make a flag variable, and I'm going to call it no more swaps. I'm going to set it to be false. I'm then going to replace the outer for loop with a while loop. While no more swaps equals false. I will explain how this works in a second. I'm then going to do no more swaps equals true. I'm then going to put in here no more swaps equals false again. So allow me to explain. This loop is going to keep repeating whenever we have to make a swap. Let me show you this visually. Okay. So what's going to happen is we're going to have this variable called no more swaps. It's going to be false. Because of that, this loop is going to run at least once. When this loop runs, we're going to assume that we don't need to make any swaps at all. So no swaps needed, basically. We're then going to do a for loop. We're going to check this 3 against this number 1. We're going to do this if statement. Is this if statement going to be true? As in, are we going to run the if statement? Or is it going to be false? We don't need to. Based on 3 against 1. Do we need to run the if statement? Yes, we do. Because 3 is bigger than 1. So we do our swap. we put 1 here, and we put 3 here. No more swaps becomes false. So I'm going to put false up here. So no more swaps, NMS for no more swaps is false. Because we do need to make a swap. Because we've made a swap, no more swaps goes to false. We carry on doing a for loop. So we're going to do 1, 2, 3, 4. So it puts it into order. So eventually the for loop finishes. We're done. We then go back to this loop again. Whilst no more swaps equals false. Well, it is false because we had to make a swap in the previous loop. Because we made a swap in the previous loop, we're going to run this again just in case. No more swaps becomes true by default. So we're assuming we don't need to make any more swaps. We're assuming we're done. We're then going to run the for loop. The for loop is then going to run the if statement. The if statement is only going to be executed if we need to make a swap. So we're here now. Do we need to make any swaps here? No. Therefore, once we finish the for loop again, with no swaps being done, no more swaps is still true. We haven't actually had to make any swaps. So when it goes back to this while loop again, we stop. So that basically means that we've looped through this 2 times instead of doing it the full 7 times previously. So the reason why we put no more swaps equals true here is we're assuming we don't have to do any more swaps. We're just making that assumption. We're guessing. The reason why we've got this becoming false inside this if statement is if this if statement ever runs, it means we've had to make a swap. So the very fact that we don't have any more swaps to make is now going to be false because we've had to make a swap. Let's try with a different example. This example is a lot bigger in terms of we have to do more swaps rather than the list is bigger. So we run the code, no more swaps is false to begin with, so we can run the loop. So no more swaps is like saying, do we need to make any more swaps? Or you get a gist. No more swaps then becomes true. We don't have to make any more swaps. We're just guessing at this stage. Because if we never need to do this, we can stop straight away. So imagine that we had our list, ignore this for a second, as 1, 2, 3, 4. Straight away. No more swaps is false. We start looping. No more swaps becomes true. We then do our for loop. We check this. Do we ever need to make a swap here? No, we don't. These numbers are already in order. Therefore, this if statement will never run. Therefore, no more swaps will never become false. Therefore, after the first time we do our for loop, after the first cycle, no more swaps is still true. We then check it against this and we're done. So we only need to loop that once. But in this scenario, let's see how it plays out. No more swaps becomes true. We then loop. Do we need to swap 5 against 2? Yes, we do. So 2, 5. 5 against 1? Yes, we do. So 1, 5. And because we've had to be doing these swaps, by the way, this becomes false again. Because we've had to make a swap. 5 against 8, no swap needed. 8 against 6, swap. 8 against 3, swap. 8 against 4, swap. So we've done our first cycle. No more swaps is false. So when we go back to the loop, whilst no more swaps equals false, repeat again. No more swaps becomes true. For I in range, we do our again, so we look at 2 against 1. Is 2 bigger than 1? Yes, it is. So guess what? No more swaps becomes false again. Because we've had to make a swap. But the moment we have to make one swap, we're going to do this outer loop again. It's just how it's going to be. So 2 against 1. Let's just reset. Let me just do it above, it'll be easier. Okay, so 1 goes here, 2 goes here, 2 against 5, no swap needed. 5 against 6, no swap needed. 6 against 3, yes, we're going to do a swap. 6 against 4, yes, we're going to do a swap. 6 against 8, no, we're not. No more swaps is still false because we've had to run this if statement at least once during that cycle we just did. So we've now done our second cycle. So we go to normal swaps equals false, we loop again. Normal swaps becomes true because we're going to assume we don't need to do anymore until we get told otherwise. Let me just move this up slightly. And let's run this bad boy again. So we're going to have 1 checking against 2. Does there need to be a swap? No. So far, we don't have to do any swaps. 2 against 5. No swaps. 5 against 3. Yes. We've had to make a swap. Because we've had to make a swap, no more swaps becomes false. Which means we will have to loop again and have another cycle. 5 against 4. Yes. 5 against 6. No. 6 against 8. No. So now we're going to go on to cycle number 3. Normal swaps is false. We then make normal swaps. Oops, didn't mean to do that. Normal swaps becomes true. We then do our checking. So, does 1 against 2 need to switch? No. Does 2 against 3 need to switch? No. Does 3 against 4 need to switch? No. Does 4 against 5 need to switch? No. 5 against 6 need to switch? No. 6 against 8 need to switch? No. Because we've never had to make any swaps, we don't do this part of the code. We don't execute it, which means no more swaps is still true. So we're basically saying we don't need to make any more swaps. So we go back to this. It checks. It's not false. It's now true. It's over. So 1, 2, 3, 4, 5, 6, 8 is perfect. We don't need to make any swaps. So we did it in 3 cycles. In the old bubble sort, we will still keep going because we'll still keep with 2 for loops. You'll still have to do it the amount of numbers we've got in the list -1 because of the -1 here. Okay, and that is our efficient bubble sort. We did it in 3 rather than 7.